Hi everyone, Sharan here. Welcome to my channel. Today in this video we are going to see about scaling. Scaling is commonly used in feature engineering, and scaling is commonly used when we are trying to use a distance-based algorithm. The reason behind it, for example, in distance-based algorithms such as KNN or K-means, when we have a feature which is of larger scale, let's say we take age and salary as an example. So age would be of a smaller scale, like between 0 and 100, whereas salary would be in higher scale, let's say if it is being measured in 100,000s. So now what happens is when we pass on these features as input to an algorithm which is using distance as a measure, like K-means or KNN. So what happens is the feature which is of larger scale, such as salary, will be very dominant in the model. So the feature which is of smaller scale, even though it might have a larger role to play in improving the accuracy of the model, because it is very small as compared to salary, what happens is it might not be able to influence the model, or it might not be able to help in improving the accuracy of the model, because there is a feature which is of a very higher scale and it becomes very dominant. So what happens is usually when we are trying to use distance based algorithm such as KNN, K-means or whatever it may be, if in case you are going to use distance based algorithm, you need to ensure that scaling is being performed in order to make sure all the features that we are going to use or that we are going to pass as input to the algorithm is of a same scale, or it is comparable. So there are two techniques that is commonly used for scaling. One is normalization and second one is standardization. The methods are like quite similar to each other. The formula slightly differs, and the way how we transform the values also slightly differs. So in case of normalization, what happens is the value would be transformed into, let's say, a range between 0 and 1. So here what we are going to do is the distribution, everything remains same. If we have a larger scale, like for example, like age and salary, so whatever be their actual scale, we will be transforming them to fit into the scale of 0 to 1. So whatever outliers that were present in the actual data, whatever the actual distribution of the source data, everything is retained. The only difference is we are just rescaling them to fall into the range of 0 to 1. In case of standardization, what happens is it is slightly different. The approach is the mean value would be 0. Whatever data set that we have, the mean value would be considered as 0 and the values will fall on the either side of 0. So it might range somewhere in a negative value, and then the mean value would be exactly 0 and again goes to the positive value. So it will be kind of a normal distribution, like the center value is considered as mean and it will have values on either side, like on the negative side as well as positive side. So that's what the standardization is. So as you see on the whiteboard, the formula for the transformation is also present in the whiteboard. So coming to the tutorial, so what we are going to do is we are going to see how to implement the scaling functionality. So we are going to pick up the Titanic dataset again, and we are going to pick up an attribute and then maybe implement this particular functionality and see what's happening. So as I have explained, so this is what the formula for normalization is. So it will be x is the actual value. The formula is x minus x minimum. So if we considered age, the value that we are going to transform is x, and x minus the minimum value for age divided by the maximum value for age minus the minimum value for age. So whatever be the feature or attribute that we are going to use, so this is what the formula will be in order to convert or normalize the particular feature. And for standardization, the formula is slightly different. It will be x minus mu, where mu is the mean, and divided by the standard deviation. So that's why whenever like the mean value will always be 0, because we are subtracting it by mean, and we will have values which is less than 0 as well as greater than 0 as well. So these two methods, what happens is if our data set has a large number of outliers, so then by scaling, by using scaling functionality, we are not treating the outliers issue. We are just transforming them into a newer scale, and we are not ignoring the impact that could occur because of the outliers. So what we are doing, what we need to ensure is if your data is having any outliers, before using the scaling functionality, you need to ensure that the outliers are treated properly. In some cases, what happens is if there is a large number of outlier, for example, in Titanic dataset, we have fair. So there are like majority of the values fall in the lower category, whereas there are few values with like a value of 500 as well. So in those cases, what we use is we use something called as an quartile cut. So whenever the values are densely populated in a certain range, we would have many categories for that particular range, and whenever there is some ranges which is sparsely populated, which means that there aren't any values falling into that particular categories, so then the ranges will be considered slightly higher. So we try to divide it into equal parts based on the number of occurrence within that particular range. So that is one method that will be very useful when your data set is having a large number of outliers. But if you don't have any outliers issue, then you can feel free to pick up any one of these functionalities like a normalization or standardization to convert the data, so that when you used a distance based algorithm such as k-means or knn, the algorithm there is no feature that is dominant because of its larger range. So that's about the scaling functionality. So going to the tutorial, what we are going to do is we are going to I'm going to just clear the output. Okay, so now I'm going to use NumPy as well as pandas for today's tutorial, and it is the same Titanic dataset that we are going to do that we are going to use for this purpose, and we are going to pick only age as well as fair. So as you see, we have age as well as fair, and we are going to create a column called normalized age, and we are going to apply the formula that we just saw here. So it's the same formula, like age minus the age minimum value, and then age maximum minus the age minimum value. So by applying this formula, what we are able to do is we are able to create a new column called as normalized age, and if we check the range of this particular normalized age attribute, so if you see the minimum value is 0 and the maximum value is 1. So whatever be the values, we are able to force it into and fall in, like make it fits into and fixed range, like between 0 and 1. In case of standardization, I'm using the same attribute age. In case of standardization, the formula is x minus mean by the standard deviation. So I'm going to apply the same formula and create a new column called as standardized age. So by executing this, I have created the new column. So now what I'm going to do is I'm going to just show you like how the data appears. So as you see here, we have normalized age as well as standardized age. So normalized age would be falling within the range from 0 to 1, whereas standardized age, the mean value would be 0, and it would have both values on the negative side as well as the positive side. So that's what you see on the screen here. So here this particular age 38 is much higher than the mean, so it is positive, whereas 22 is less than the mean value, so it is negative. So that's how the data would look like. So if I see the range here for the standardized age, so here in this case the range is somewhere from -2 to 3. So it doesn't fall into an fixed range. So the mean will always be 0, and depending upon how the data is distributed, the values might extend on the negative side as well as the positive side. But what we are able to do is we are able to rescale it, and hence after rescaling, so then in case of any distance based algorithm that we are going to use, we can use all the attributes. So that's about like the technique that is commonly again used in feature engineering. So now I guess you would understand when we can use scaling. So whenever you have a distance-based algorithm, whenever you want to use distance-based algorithm, let's say you have some data and you want to identify various clusters in the data, so you would be using k-means algorithm in order to identify various clusters. So when we say identifying various clusters, what it means is we are able to identify various clusters based on the distance between them. So if we have many features and one feature is having a scale on a very higher range, so then that will become more dominant, and the more important attributes which is of smaller range will not be able to influence in predicting the actual clusters. So that's why we use a scaling, and we ensure that all the input are of the same scale, and then we use the distance-based algorithm. Like in this case, we can use k-means in order to identify the clusters. So then the clusters that we identify will be more accurate. That's it about today. I guess you would have learned something new today. If you have learned something new today, please give a thumbs up and subscribe to my channel, and please don't forget to enable the notification icon to ensure that all my videos reach you. And that's it for now. See you on some other day. See ya. Bye.